Welcome, my name is Kenneth, TPM at AccelByte, and I'll be your host today. Multiplayer mode is surely a very attractive feature for any game, but building one means that the game developer must maintain a back-end system that has features like user account management service, friends and online presence service, entitlement, and even payment service. And in addition, if you want a full-fledged, high-performing multiplayer experience, then you must have a robust matchmaker to put similarly skilled players to play in the same gaming session, and then have an elastic fleet management service that can spawn or collect the game sessions when they are required or done. Building all these features and services takes massive amount of effort that can be otherwise dedicated to make your game more fun. So here at AccelByte, we build online services for games to scale to millions of players so that the game developers can focus on the game, not the backend. We are founded by industry veterans who have engineered online systems for some of the largest game and distributed platforms, such as Epic Store, Xbox Live, PSN, and Origin. Our product, the AccelByte Cloud, is a set of all-encompassing game services that aims to let the game developers focus on making their game. The Matchmaker and Armada fleet management service that is covered in this webinar are actually part of the AccelByte Cloud. They are covered together because they have a fairly extensive feature set and they cannot work without each other. So in this webinar, I will first give you an overview on both the Matchmaker and Armada individually. Then I will briefly describe how they work together, and finally I will demonstrate how these features can be configured in our admin portal in the tech demo. So matchmaking in AccelByte is actually driven by you, the developer, so you can matchmake your players using any arbitrary values such as score, skill level, and even latency. Apart from the latency, these attributes can be uploaded directly from your dedicated servers to the AccelByte stack service at the end of each game so that you can utilize those statistics during the next matchmaking process. On the other hand, latency is obtained by getting the lowest ping from the client to the quality of servers that are located in every data center that your Armada manages. For those games that have multiple game modes, you can define a specific rule set for each game mode. For example, for a competitive shooting game, you can have a practice game mode that basically has no criteria to match, so that the match pops up a lot more often, and then a later game rule set that is when you actually want to match players with similarly skill rating. Our matchmaker also supports advanced features like the rule flexing and backfilling. Rule flexing is the ability to relax matchmaking rules after a player starts matchmaking but is unable to find enough players to play with after an extended period of time. So that period of time is defined by you, and the matchmaker will allow a set of more relaxed matchmaking rules after that time so that the player can be matched with other players more easily. In addition, this flexing, you can set multiple flexing rules so that you can structure the matchmaker to gradually relax the matchmaking rule set over time. Backfilling is the ability to register an ongoing match again in the matchmaking queue, so that any empty spots in the match can be refilled again by the matchmaker. These features make it extremely easy to fill an empty spot after a player had unfortunately disconnected from the match for whatever reason. Next, we are going to take a look at Armada, our powerful fleet management service. The main responsibility of Armada is to orchestrate dedicated servers across data centers. So depending on your setting, you can have a few servers pre-spawn on data centers of your choosing, or have them spawn on demand. For those games that have very different game rules in each game mode so that they require different server binaries to handle, you can define how many servers to pre-spawn for each game mode and in each game data center. Once a match is found, depending on the latency of the players within the match, Armada will retrieve or spawn a dedicated server on the data center that has the lowest shared latency among the players. It will then write the participants' data into the dedicated server and return the connections to the player. When player connects to the dedicated server, the dedicated server will check the identity of those player against the participant data that was written by Armada, so that it is indeed the player who is allowed into the match. Armada also does not have to inhabit one cloud. It is designed to manage multiple clouds and bare metal providers. So this opens up the possibility for your environment to take advantage of the best of the cloud and bare metal providers. For example, you can run your bulk of the dedicated servers in the relatively cheaper bare metal machines, and then when the demand exceeds their capacity, then you can utilize the elastic nature of cloud services to fill in the gap. Finally, to ease the complexity of development and testing, Armada allows the registration of local servers as dedicated servers so that you can do your development locally. After you are happy with the state of your server, you can then upload the server to AccelByte Cloud using our dedicated server uploader to take advantage of the fleet management service. So if I have done an okay job so far, I believe you have some understanding of the Matchmaker and Armada. So I believe this is a good time to walk through with you guys how they actually work together. This is the high-level flow of the Matchmaker and Armada. As you can see, the entities are players, lobbies, Matchmaker, and Armada, which composes of the dedicated server manager, the fleet manager, and the dedicated server themselves. Before going into the flow, I would just want to take a moment to talk about lobby. Lobby in AccelByte Cloud is essentially a hub that serves features that require persistent connections. So, as you can imagine, servers like chat, friends present servers, and obviously the Matchmaker are served by the lobby. So obviously, to access the Matchmaker and Armada, the player has to connect to the lobby first. Then he will send a matchmaking request to the Matchmaker. The Matchmaker will then work its magic by finding suitable players to putting them together in the same match. This will take a while since there are not always enough players to be matched, and sometimes it will reach the matchmaking timeout and begin. So the Matchmaker will begin flexing the rules a bit. So either way, the Matchmaker will report to the players if a match is found successfully or not. And in a successful case, the lobby will forward a create session request on the player's behalf to the Armada DSM. So now Armada will do three things. Firstly, Armada will check with the fleet manager if there's any available DS or not. If there's no dedicated server, then it will request it to spawn one. And after that, it will claim a available server, and the DS fleet manager will assign the dedicated server to the matchmaking session and report it back to DSM that a dedicated server is indeed claimed. So after that, the dedicated server manager will then forward the dedicated server session back to the lobby, and the lobby will notify the player that a session is ready for them and forward information such as the IP ports, connection detail back to the player. So now the player clients will then use the connection data to connect to the game server directly. So I've covered a lot of features, but what you are going to do to integrate and utilize the Matchmaker and Armada is actually fairly simple. So in the coming tech demo, I'm going to show you how you can configure them and talk a little bit more in details about some of the key concepts of Matchmaker and Armada. So to start, I would first want to talk about Like Fantastic. It is a game that made by us to demonstrate how you can integrate with AccelByte Cloud in a client. That is, you can download the source code from here, and for Light Fantastic, it is built by Unity. And we also have a sample project for Unreal, and it's called AB Shooter, and you should be able to find it in the same repository. So back to the demonstration, to start, you would probably want to configure your matchmaking rule set. So to do that, you click on matchmaking rule set here, and then you click Add Configuration. So the first thing is game mode. Game mode is basically whatever string that you want to name your game mode. So for the purpose of this webinar, we just call it demo. I call it default, but you can really name it as anything that you would understand, like 1-to-1 PvP, or say free for all 20 players. So this is the namespace of the game. So namespace is really a game in this context. So it is a unique identifier to identify your game. And next, you want to set the timeout for matchmaking. So this is basically the time that the players is allowed to stay in the matchmaking queue to find a suitable opponent. So for the purpose of this webinar, we set it as 30 seconds, but you probably want it a lot longer, like 5 minutes or so. So next, there's a setting to define whether the session is joinable. A joinable session basically means that the session can be joined again once it has started. So for whatever reason a team member had disconnected, you can then re-queue this session back to the matchmaking queue to fill that spot. So if joinable is not checked in here, your match session cannot be queued again in the matchmaking queue. So the timeout here basically means how long it stays in the matchmaking queue. So for the purpose of this demo, I'll just say 30 seconds. So this setting, dedicated server service, is basically how you set a game mode to run in a specific dedicated server. So if you have multiple binaries that support multiple game mode, this is where you want to set those settings. And if it's left empty, the default dedicated server will be used. So in the description, I will just say it's just identified as no specific feature that is rely on this description. So I will just say like fantastic 1v1 default. Done. So that's done. So in this session, in the rule set session, you are basically telling the matchmaker how many users, how many players will you fill in your matchmaking session. So it is divided by two parts. It has a team number setting and it has a play number setting. So the play number setting is actually the number of players in a team. So if you want a team of 2 against each other, you would probably say max team number equal to 2 and max player number equal to 2. So since this is a 1v1 kind of game mode, so the appropriate thing to set here is max team equal to 2 and max player is equal to 1. So that looks good, and I'll proceed to save it. Next, let's take a look at the Armada side of things, which is all located in this session, dedicated server management. So if you click in the servers, it gives you an overview of the health and the performance of your dedicated servers managed by Armada. So since we have nothing running here right now, we have local server equal to 0, server overviews, the number of servers equal to 0, available region is 1, which is here, US West. And if you click into available regions, you will see the location of the quality of service servers, which is located in this IP and this port and is active. So finally, total sessions mean how many running active game sessions it is now. So since there's no game running, it's 0 right now. So next, let's configure Armada. So the first thing that you see is the timeouts. So what it means is there's a number of timeouts that you need to set. The creation timeouts is the timeouts before your dedicated server finishes creating itself. So you need to load your binaries, right? So if the loading time of the binaries exceeds 60 seconds, it will fail, and the dedicated server manager will collect that dedicated servers. So same goes with claim. So after the dedicated server is created, as I mentioned before, the fleet manager will attempt to claim a server. So if that exceeds 120 seconds in this setting, then it will fail again, and the DSM will collect the dedicated server. So session timeout is very important here. This actually means the maximum time that your game will go on until your dedicated server is collected. So if you set it too low, then there is a possibility that your games will be collected before it finishes. So please be careful with this setting. So unreachable timeout finally is if the timeout that the dedicated server use basically every dedicated server has a heartbeat. So this timeout is when the dedicated server manager has not received a heartbeat after this number, then it will go to unreachable, and then it will be collected eventually. So the protocol here just means the protocol that you use to connect to your server. So it can be TCP or UDP. So next, you want to say the ports of your server. You can actually add additional ports if you want more than one port to work. But for the purpose of this, I would just say we'll just have one port here. So the providers is the service provider. In our case, AWS. And if you want to add more service providers, you have to reach out to our engineers to actually add it for you. So there's no self-service capability here, because it will also affect how we deploy your environment. How we'll need to have our engineer to configure cross data centers, cross service providers, type of Armada services. So finally, in the final section, the image version basically means not the images that you uploaded onto Armada. So for this environment, we only have one dedicated server image uploaded, and I've set it as default. And I will show you later how you actually upload a dedicated server. But for the time being, let's look at port configuration. So port configuration is the amount of resource that will be taken by each server according to the image. So the limit is actually a hard limit. So if your servers takes more than this, say if for the default server I have 250 megabit allocated for it and 100 megahertz CPU allocated to it. If your server, if running your server actually exceeds this limit, then it will fail. So we pay more attention on this setting, and in general speaking, the lower it is, the better. But you also want it to run your server properly. So if you set this number extremely high, like if you take 1,000 megahertz and then 1,000 megabit, it will actually take resources from the data center, so you will have less ability to run more servers concurrently. So lastly, deployment. Deployment is basically how the servers are deployed. You can have a different setting for different image version. So this is actually how you set number of pre-spawn image in a number of regions, and how many server you want to pre-spawn on a data center. So let's take a look, because now mean count is 0 and buffer count is 0. So if we want to say pre-spawn 1 server, then we will set mean count is equal to 1, buffer count is equal to 1. Basically means that now there is a minimum server of 1 server running, and I only want 1 server in the buffer. I actually need to click this. Yes, I actually need to click this. So after that is set, we can return to the server. Refresh it a little bit. It actually takes time to spawn. There we go. Now it's running. 1 server is creating. As you can see, is running. And if you want to go more, you can say 2. Now let's see if we can do 2. 2 mean and 2 buffer. And yeah, it takes a little bit of time. Yep, there you go. So this is how you pre-spawn and pre-spawn your servers and configure it in a way that you have a limit of how many buffers you want to pre-spawn, and you want to limit the resource of your servers so that it won't go, say, beyond 5 to save resource on your data center. I have shown you how you would want to manage your dedicated server using Armada. Now I'm going to show you how you want to develop with our local dedicated server. So the server that I'm going to use is straight out of the box from LifeFantastic, which has an integration with AccelByte Unity SDK. So as long as you have integrated with either the Unity SDK or the Unreal UE4 SDK, you have a out-of-the-box free functionality to use local dedicated server. So to run the server, you run the binary, and then you specify the parameter as local DS. What this means is it tells Armada that this server is running locally, and it will direct any traffic from my machine to this local dedicated server. So now let's run this. Now it's running. So to verify, you can go back to servers page, and now you see server. There's one local server running in here, and if you take a closer look, it is created recently and it is ready to use. So you can use this local dedicated server to help your development and so that you can quickly test your features and whatnot. After you are happy, you will want to upload your local servers onto Armada so that it can be managed. So to do that, we actually build a uploader specifically for this case. So let me just turn this off first. And this is the uploader, and it is built in Linux, Windows, and Mac. So you should be able to access it. And this is actually the upload script, but I'm not going to show it here because it contains confidential information like client ID and client secrets. But it is just one command line that is well documented, so you should not have any problem writing this command line. So let me just upload it. And this process will take a while. It took a while, but the upload is complete. Now we want to double check if the image is actually managed by Armada. To do this, we go to the configuration section and scroll all the way down. Under the image version, you just see a new entry. This is the server that we just upload. To use this as a default image, we just click the tiny input box here and set it as default. What it does is it tells Armada to collect all the old images and spawn new ones using the new images. So to conclude, during this webinar, I've shown you that the AccelByte Matchmaker is highly customizable. It supports matchmaking using arbitrary values and latency, game mode specific matchmaker, rule flexing, and backfilling. Armada is a powerful fleet management service that supports on-demand dedicated server spawning and despawning, cross-data center dedicated servers management, spawning game mode specific dedicated servers, easy adoption of local servers for development and testing, and hosting on cloud or bare metal servers, or a hybrid hosting model that utilizes both. I've also shown you how easy it is to configure the Matchmaker and Armada in the out-of-the-box version of AccelByte Cloud. This concludes the webinar. Thank you for staying with me this far. If you have any questions, please feel free to send us an email or leave us a message in our Discord channel. Thank you.